Hi, you are watching Math Club. Today we are going to discuss the expansion and simplification of algebraic expressions. Let me define an algebraic expression. We know that when constant and variable terms are connected by basic algebraic operations, they form an algebraic expression. A constant does not change its value over time, while a variable changes its value depending on the equation. Constants are usually written as numbers and variables are represented by letters or symbols. Now let's discuss another important point related to the product of algebraic expressions. When we multiply an algebraic term by another algebraic term containing the same variable, the coefficients and variables are multiplied separately. In this video, I will cover how to combine like terms and how to use the distributive property to do so. Remember, like terms are terms with the same variables raised to the same powers. When we combine like terms, we look for any like terms in the given algebraic expression and combine them into one term. The reason we combine the like terms is to simplify the algebraic expression. Let's solve some questions related to the expansion of algebraic expressions. These questions are from exercise 3A in the new syllabus mathematics book 2 chapter 3. Let's jump into number 1 where the question states that expand and or simplify each of the following expressions. We have 4 terms in this expression: positive 6x squared, positive 19, positive 9x squared, and negative 8. I'll combine positive 6x squared and positive 9x squared because both of these terms are like terms with the same variable x and the same power. When we combine like terms, we add or subtract the coefficients, the numbers in front of variables. The coefficients of the first 2 terms are positive 6 and positive 9. So adding them gives 15. Therefore, we combine 6x squared and positive 9x squared to get 15x squared. Remember, this simplification does not change the value of the expression. Next, we have constant terms 19 and negative 8. Combining these gives us positive 11. Now we have 15x squared and positive 11, which are unlike terms and cannot be added or subtracted further. Thus, the simplified expression is 15x squared positive 11. Remember, the expression 15x squared positive 11 is equivalent to positive 6x squared positive 19 positive 9x squared negative 8. Let's move on to number 2, where we have positive x squared, positive 2x, negative 7, negative into negative 11x squared, negative 5x, negative 1. First of all, I'll simplify what is in the parentheses. I'll multiply the negative sign by negative 11x squared, which gives us positive 11x squared. Now, I'm going to combine like terms in this expression. We have positive x squared and positive 11x squared with the same variable x and the same power. Next, we have positive 2x and negative 5x with the same variable x and the same power. Remember, when we don't have an exponent attached to a variable, there is an understood exponent of 1. Anything to the power of 1 is just itself. Next, we have constant terms negative 7 and negative 1. When we combine like terms, we add or subtract the coefficients, the numbers in front of the variables. The coefficients of the first 2 terms are 1 and 11. So adding them gives us 12. Therefore, we combine x squared and positive 11x squared to get 12x squared. Now, positive 2x and negative 5x give us negative 3x. And last but not least, negative 7 and negative 1. Combining these gives us negative 8. Thus, the simplified expression is positive 12x squared, negative 3x, negative 8. Remember, the expression positive 12x squared, negative 3x, negative 8 is equivalent to positive x squared, positive 2x, negative 7, negative into negative 11x squared, negative 5x, negative 1. Let's move on to number 3, where we have y plus, and then we have in parentheses negative 3y squared, positive 2, and then in parentheses y squared negative 6y. If we multiply this positive sign by negative 3y squared, that gives us negative 3y squared, because positive times negative is negative. And now positive 2, and then in parentheses y squared negative 6y. We are going to do this by using the distributive property. So I'm going to take that 2 on the outside of the parentheses and distribute it to the y squared and to the negative 6y. So we have 2 times y squared plus 2 times negative 6y. 2 times y squared gives us 2y squared. And positive 2 times negative 6y gives us negative 12y. Remember, distributive property does not change the value of an expression, because positive 2y squared negative 12y is equivalent to 2 into y squared negative 6y. Now, I'm going to combine like terms in this expression. We have negative 3y squared, positive 2y squared with the same variable y and the same power. Next, we have positive y and negative 12y with the same variable y and the same power. Negative 3y squared, positive 2y squared gives us negative y squared. Positive y, negative 12y gives us negative 11y. Negative y squared, negative 11y are unlike terms, so we don't have any terms that we can combine. So we are done here. Negative y squared, negative 11y is our simplified expression. Let's move on to number 4, where we will apply the distributive property to an algebraic expression. In order to simplify the expression, we are going to remove the parentheses. For number 4, we have positive 5x squared, negative x, negative, and then in parentheses positive x squared, negative 10x. Remember, when we don't have a coefficient in front of a variable, or just like the negative sign in front of the parentheses, there is an understood coefficient of 1. Now we can't combine those terms in parentheses because they are different terms with the same variable x but different powers. So what we can do, we can use the distributive property to remove those parentheses and simplify this expression. So let's distribute the negative 1 to the x squared and to the negative 10x. This gives us negative 1 times x squared, negative 1 times negative 10x, or negative times x squared and negative times negative 10x. Negative 1 times x squared gives us negative x squared, and negative 1 times negative 10x gives us positive 10x, or negative times x squared gives us negative x squared, and negative times negative 10x gives us positive 10x. Now, I'm going to combine like terms in this expression. We have positive 5x squared and negative x squared with the same variable x and the same power. Next, we have negative x and positive 10x with the same variable x and the same power. The coefficients of the first two terms are 5 and negative 1. That gives us positive 4. Therefore, we combine positive 5x squared and negative x squared to get positive 4x squared. Now, negative x and positive 10x give us positive 9x. Remember, we don't have like terms in positive 4x squared and positive 9x that we can combine. So we are done here. Positive 4x squared, positive 9x is our simplified expression. Let's move on to number 5, where we have negative and then in parentheses positive 4x squared, positive 9x, positive 2, positive 3x squared, negative 7x, positive 2. I'm going to distribute the negative sign before the parentheses to the positive 4x squared, to the positive 9x, and to the positive 2. This gives us negative 4x squared, negative 9x, negative 2. The last three terms will remain the same. So now let's go ahead and combine the like terms. I'll combine negative 4x squared and positive 3x squared because both of these terms are like terms with the same variable x and the same power. Next, we have negative 9x and negative 7x with the same variable x and the same power. Next, we have constant terms, negative 2 and positive 2. Combining these gives us 0. Negative 4x squared, positive 3x squared is negative x squared. And negative 9x, negative 7x is negative 16x. Now we have negative x squared and negative 16x, which are unlike terms and cannot be added or subtracted further. Thus, the simplified expression is negative x squared, negative 16x. Let's move on to number 5, where we have negative and then in parentheses positive 1 and negative 7y, negative 8y squared, positive 2 into y squared, negative 3y, negative 1. I'm going to distribute the negative sign before the parentheses. Remember, if we can't see a number in front of the parentheses, we can always write in the number 1. So what I can really change this problem to is like negative 1 and then in parentheses 1, negative 7y, negative 8y squared, positive 2 into y squared, negative 3y, negative 1. It means that I'm distributing a number. I'm distributing a negative 1 to the positive 1 and then a negative 1 to the negative 7y and then a negative 1 to the negative 8y squared. That gives us negative 1, positive 7y, positive 8y squared. So you have to make sure whenever you see a negative sign outside parentheses, you are distributing it like it is a negative 1. And if I distribute positive 2 to the positive y squared and then to the negative 3y and then to the negative 1, that gives us positive 2y squared, negative 6y, negative 2. So now let's go ahead and combine the like terms. I'll combine positive 8y squared and positive 2y squared because both of these terms are like terms with the same variable y and the same power. Next, we have positive 7y and a negative 6y with the same variable y and the same power. Next, we have constant terms -1 and -2. Combining these gives us -3. Now positive 8y squared, positive 2y squared is positive 10y squared. Positive 7y, -6y is positive y. Thus the simplified expression is positive 10y squared, positive y, -3. Question 2 states to find each of the following products. In mathematics, a product means to multiply. When we multiply algebraic expressions, we are combining the expressions. And the two expressions that make up the product are known as factors and multiplicants. Remember, in the multiplication of algebraic expressions, when two terms have the same sign, their product is positive. And when they have opposite signs, their product is negative. In algebra, we can multiply algebraic expressions together, regardless of the pronumerals they have. Additionally, in addition and subtraction, we look for like terms. But in multiplication, we don't need like terms. We can multiply like or unlike terms together without any restrictions. So let's move on to number 1, where we have 12 times 5x. To multiply 12 by 5x, we multiply the constant term 12 by the coefficient of the variable term 5x, which gives us 12 times 5, 60x. Moving on to number 2, where we have x times 6x. Since both terms have the same variable x and the same power or exponent 1. First, I am going to multiply their coefficients. The first term x has a coefficient of 1, while the second term has a coefficient of 6. Remember, when there is no coefficient attached to a variable, there is an understood coefficient of 1. So we can also write x as 1x. Therefore, their product is 6 times 1 is 6, and x times x is x squared. Let's move on to number 3, where we have in parentheses -2x times positive 8x. We don't need to look for like terms. The first term is negative and the second term is positive. So -2 times positive 8 is a -16, and since both terms have the same variable x with the same power of 1, so their product is x squared. Remember, in multiplication, the powers or exponents of the same variables are added. So the simplest form of -2x times positive 8x is -16x squared. Moving on to number 4, where we have two negative terms, -3x times -10x. To find their product, first we multiply their negative signs, which gives us a positive sign. Next, we multiply the coefficient 3 by the coefficient 10, which gives us 30. And finally, the product of the variables x gives us x squared. Therefore, the simplest expression is 30x squared.